A friend of mine asked me a question one evening that sounds simple but runs surprisingly deep. Given that energy can never be created or destroyed, what happened before the Big Bang? And where did all the energy come from? Like many puzzles, this one hides two quiet assumptions: that there could be a space with absolutely nothing in it, and a time before the Big Bang. Let us take those assumptions apart. Begin with a deceptively simple question. Imagine absolutely empty space. No matter, no energy, no fields, nothing at all, stretching infinitely in every direction. Now pick any 2 points within it and ask what could possibly tell them apart. Neither point is hotter than the other, for there is nothing there to have a temperature. Neither is denser, for there is nothing to be dense. Neither stands nearer to any landmark, because there are no landmarks. The 2 points share every property. They are equally, perfectly nothing. And here is the puzzle. If there is no way, even in principle, to tell two things apart, in what sense are they two things at all? In the 17th century, the philosopher Gottfried Leibniz turned this into a weapon. His principle, the identity of indiscernibles, says that if two things are alike in every respect, they are not two things at all, but one and the same. Apply it to empty space, and the conclusion is startling. If every point of empty space is exactly like every other, there cannot be many distinct points. Absolute empty space, Leibniz argued, is impossible. Leibniz had a deeper reason to distrust it. He believed that everything must have a sufficient reason for being one way rather than another. But picture the Creator about to place the universe in absolute empty space. Here or 3 feet to the left? Since every location is identical, there could be no reason to prefer one over the other. A choice with no possible reason, Leibniz thought, is incoherent, so absolute space cannot be real. Isaac Newton was unmoved. Yes, he granted, the points of space share all their properties, but they can still be distinct simply by being this point rather than that one. Philosophers call this thisness, and such things bare particulars, two in number, yet identical in every quality. It rescues absolute space, but at a price, a universe stocked with infinitely many featureless, mysterious somethings. Notice the pattern. To make sense of empty space, we keep having to conjure somethings, Newton's featureless points, into being. And this points to a deeper trap. To so much as say that something does not exist, you must first, in some sense, summon it into being, so that there is something for your denial to be about. Non-being, as Quine put it, must in some sense be. He gave this tangle a name, Plato's beard, and warned that it has dulled the edge of Occam's razor ever since. Hold on to it, because the very questions we began with are snared in it. Leibniz's own solution was radical. Space is not an independent thing at all. It is nothing but the web of relations between objects, the distances and directions that real things bear to one another. There is no space sitting in the background. Distance exists only between things. Think of two trees. You can measure the distance between them and name the direction from one to the other. But can you measure the distance from a tree to nowhere, or the direction from a tree to sheer emptiness? The questions collapse. Distance and direction mean something only between actual things. Strip away all matter and energy, and no space is left behind, not even empty space. For 3 centuries, the debate seemed trapped between Newton's container and Leibniz's relations. Then Einstein changed the game. In general relativity, Space-time is neither a passive stage nor a mere web of relations. It is a real, physical thing, but a dynamic one that bends and curves and stretches in response to matter and energy, and even carries energy of its own. In a sense, Einstein reconciled the old rivals. Like Newton, he made space-time real and substantial. Like Leibniz, he denied that it was absolute and unchanging. And beyond them both, he showed that space-time is itself a physical field, shaped by everything it holds. This reframes a familiar riddle. If the universe is expanding, what is it expanding into? The surprising answer is nothing. Picture dots on the surface of a balloon. As it inflates, the dots drift apart, not because they slide across the rubber, but because the rubber itself is stretching. To a creature living on that surface, there is no outside. Our universe expands in just this way. Space itself stretches from within. So the Big Bang was not an explosion at some location in a space that already existed. There was no space for it to happen in. The Big Bang is the emergence of space-time itself, the birth of space and time together. Which brings us back to my friend's question. To ask what came before the Big Bang assumes that time could exist on its own, apart from events. But time, like space, is relational. It is the order of change, of one physical state giving way to the next. Without processes, there is no time. There was no before, because time itself began with the universe. To ask for a moment before time is like asking to travel north of the North Pole. At the Big Bang, general relativity itself breaks down at what physicists call a singularity, a boundary where the very framework of time no longer applies. Stephen Hawking made the idea vivid. Near the beginning, at the quantum level, the line between space and time blurs, and time becomes, in a mathematical sense, just another direction of space. The universe has no first moment and no temporal edge, just as the Earth has no point south of its southern pole. Time simply emerges, and so the puzzles dissolve. Remember Plato's beard, the temptation to treat nothing as though it were something. That thread ran through all of it. To ask what came before the Big Bang is to treat an empty time as a real expanse. To ask where the energy came from is to treat an empty space as a real place. But space and time are not pre-existing containers waiting to be filled. They are features of the physical world itself, relational, dynamic, and emergent. There is no before, because time began with the universe. There is no outside, no empty space from which energy had to come. Space-time and energy arose together as a single whole. Trim the beard, and the questions are not so much answered as dissolved away.